In this video, I just need to explain what relative density means. Now, the word relative kind of means to relate to something. Now, in this case, relative density means I'm relating the density of a substance to the density of water. Maybe let me use some illustration to paint the picture of what I mean by relative density or relative something. Right before me here, I'm having 3 sticks. They're just sticks I've wrapped with paper. So there is this stick, there is this one, and then there is that one. I am a kindergarten mathematics teacher, and I need these sticks of this height so that I use them to help me in counting as I'm teaching addition to kindergarten kids. So now what happens is that I send out some kids to go to the forest or to the bushes to just go and cut down some of these sticks, like of this size. So of course, as these kids go to cut down these sticks, they come back with various sizes of sticks. This is my standard height. This is the height of the stick that I want. But however, as these kids go out to cut the sticks, some of them come back with sticks that are shorter than my standard height or the standard height that I want, and some are coming back with sticks that are longer than the standard height that I want. Maybe I can't afford to have all the sticks of the standard size that I want. So I decide to make a compromise and I say, okay, I'll tolerate some sticks that are probably that are not very far away from the standard size that I want. So if I want to determine the sticks that are not very far away from the size that I want, the standard size that I want, then it means I'm going to start carrying out I may carry out what we call the relative height of the sticks. Now, by relative height, I mean that I am going to get my standard stick size, which is this one, and I am going to compare the height of this stick with the height of all these other sticks that they've brought. That is what we are calling relative height. So in this case, the relative height is going to be it's going to be a ratio, or it's going to be an index, or it's going to be a number that is going to show me how high the other sticks are in relation to my standard height. So I'll call that relative height. So let me just do an illustration on just these 3 sticks. So now we are having these 3 sticks. We have stick A, stick B, and stick C. And I am saying that stick B is going to be more of like my standard. I sent these kids out into the bush, and I expect that they get me sticks of this height specifically. But in the process, they got me sticks that are shorter, and some got me sticks that are longer than my standard height. So let's assume my standard height is 10 centimeters. So the standard height of the stick that I want is 10 centimeters long. So meaning that if one of the kids gets me a stick that is taller than this one, then I can go ahead and find how long is this stick in relation to my standard height. If somebody went and got me a stick that was shorter, I would go and say, how long is this stick in relation to my standard height? So what do I do? So I'll go ahead and find the relative height of stick C. So it means that the relative height of stick C is going to be equal to, what I'm going to do is that I'm going to measure the height of this stick C. Let's say the height of this stick C is 20 centimeters. So it's going to be the height of stick C divided that by the height of my standard stick, which I'm calling stick B. And in this case, the height of stick C is 20 centimeters with this long one, stick C. Divide that by the height of the standard height, which is 10. And I'm going to get this is also in centimeters. Of course, the units will cancel out. 20, this gives us 2. And so it means that my relative height, the relative height of stick C is 2. Let's look at the relative height of stick A. So the relative height of stick A is going to be the height of stick A, divide that by the height of the standard height, which is B. The height of stick A in this case, let's assume this is 5 centimeters. It's halfway, this one. It's an assumption. So this is 5 centimeters, divide that by 10 centimeters, and we shall end up with a half. So now why am I making these calculations of relative height? I'm trying to explain the significance of what we mean by relative height. Like I said, this is my standard height, B. This is the height I want. It's the height I've chosen. It is my standard height, B. But then now, some sticks are taller. So in finding the relative height of stick C, we divide the height of C, divide that by the height of the standard, the base height. And we got 2. But when we did this, when the thing was shorter, for all the stick that was shorter than my standard, the height of A, divide that by the height of stick B, I got a half. Now, the question is, what do these figures mean? This is what they mean. It means that relative height, if the relative height of stick C is 2, it means that this stick is 2 times taller than my standard height. That is what it means. Likewise, this half, which is relative height, a half, this a half means that this means that this stick is halfway the height of my standard height, B. They're just ratios that help us to know the magnitude of something in relation to something. For example, when I just look at 2, I know that this stick C is 2 times taller than this one. Let's say I got some other stick, and let's say I got its relative height to be, let's say, 6. It would mean that that very stick is 6 times taller than the standard height that I want. That is why we are dividing this by the standard height. We are dividing this by the standard height B. Why? Because this height is what I wanted. So that is the concept of relative height. Now I want us to relate this to what we mean by relative density. It is going to be exactly the same thing here. Like in my earlier illustration where I was using sticks, the same reasoning I used there is the same reasoning that is at play here. That relative density is simply the ratio of the density of a substance over the density of water. So in this case, the density of water is our standard. I know that the relative height of this stick is 2. This means that this stick is 2 times the height of my standard height. So it means that if I just only know that if I just know the relative height of this stick, and I know the height of my original, let's say this is 10 centimeters, so meaning that if I want to find the real height of this stick and I know its relative height, I'm simply going to say it is 2 times the height of the standard, and I'm able to get the height of this thing. Likewise, the relative height of this is a half, right? So it means that if I want the height of A, and I know its relative height to be a half, it means that it is a half of the standard height that I had chosen, the standard stick. So if I need to find the height of this, I'm simply going to get a half, multiply that a half by the standard height, and I'll be able to get the height of this stick. So that is going to play out exactly the same even when we're dealing with relative density of substances. Let's say I have the relative density of a certain liquid to be like, it's 3. That's relative density of a certain liquid X, it's 3. If I want to find the density of that very liquid, I know it's simply going to be 3 times the density of water. Now we all know that the density of water is 1,000 kilograms per meter cubed. So it's going to be 3 times the density of water, and I'll be able to get the density of that liquid X. So when it comes to relative density, by definition, relative density is simply given as the ratio of the density of the substance to the density of water. That is in general terms. However, the formula for relative density can be represented in many other ways. So, like we said, relative density is density of substance over density of water. Density is equal to mass over volume, so it is mass of the substance over volume of substance. Divide that by the mass of water over volume of water. Of course, because we are dividing these two, the reciprocal of this is a volume of the water over mass of substance. Multiply that by mass of substance over mass of water, and definitely this volume of water and volume of substance, they will cancel out. it means that the volume of this substance and the volume of the water are the same for them to be able to cancel out. And when they cancel out, you remain with relative density being equal to mass of substance over mass of water. So what does that mean? This gives us another formula for relative density. So relative density can also be defined as the ratio of mass of a substance to the ratio of mass of an equal volume of water. It is important that it is an equal volume of water because these volumes cancel out because they are equal. Otherwise, if these volumes are not equal, then this would not hold. That is why the other way we can look at relative density is the ratio of mass of a substance to the mass of an equal volume of water. Now we also know that mass is directly proportional to weight. I mean, we all know that weight is given by mass times gravity. Gravity is a constant term. So it means that weight and mass are directly proportional. The higher the mass, the higher the weight. The lower the mass, the lower the weight. So much as we are saying that relative density can be given as the ratio of mass of a substance divided by the mass of an equal volume of water, it means that in the place of mass we can also say relative density can be given as also the ratio of weight of a substance to the weight of an equal volume of water. Now, so far we have looked at 3 ways we can express relative density. Relative density can be expressed as the ratio of density of a substance to the density of water, the ratio of mass of a substance to mass of an equal volume of water, the ratio of weight of a substance to weight of an equal volume of water. That is in general terms. Now let's look at other ways of finding relative density. Let's look at how we can find relative density in solids. Now when it comes to solids, the relative density can also be given as mass of a substance in air divided by the apparent loss of mass in water. Now, what is this apparent loss of mass in water? Now, of course, when you are in water, you experience a certain force that acts on you. I'll use this simple illustration, but we shall explain this further when we are looking at Archimedes' principle. This right here is probably a spring balance, and this is a support of this spring balance, and this is a solid. This is a solid in air, and definitely when it is in air, we will be able to read off its weight. Now, when it comes to this, we can still bring this solid and put it in water and still read the spring balance. Now you realize that when the spring was in air, when this solid was in air, let's say it weighed, let's say 10 newtons, according to the spring balance. But then I got this very spring balance and dipped this solid in water, and when I dip it in water and then I read my spring balance again, I find that the spring balance here is, let's say, 9 newtons. Now the question is that why is it that when it is in air it is 10 newtons, and then when I come and bring the same solid and immerse it in water with the same spring balance, it's going to measure less than it did here? This is because when this thing is immersed in water, it is experiencing a certain force acting from downwards. This force that it is experiencing from downwards is going to cause it's going to cause the spring balance to record a lesser weight. In other words, this block or this solid loses some weight as it drops in water, and now that weight is lost because of a certain force that is within water, and that is the upthrust force. Of course, when this solid is in liquid, it's going to experience forces on all sides, but the downward force is the one that is the strongest, and it is the one that causes this drop in. This drop in the weight is what we are calling the apparent loss of the weight of this solid. That apparent loss, we get it by that apparent loss is gotten by, we get the weight of that solid in air, subtract the weight of that solid when it is in the liquid. When you subtract those two, the weight in solid in air and the weight in solid in liquid, we get the apparent loss of weight of that solid. Now that apparent loss of weight of that solid is because of the upthrust. We shall discuss more about this upthrust force when we are dealing with Archimedes' principle. So now this apparent loss in weight is what we are talking about in this denominator here. That the relative density for solids, we can get it first by determining the mass of the substance in air, which is what we are doing here, dividing that by the apparent loss of the mass when the thing is in water. And that's how we can get. So since mass and weight are directly proportional, it's the same story here. We can look at it as mass or weight. We can say mass, weight of a substance in air, divide that by the apparent loss in weight of that solid substance in water. And like I have been explaining, that apparent loss in weight or mass is given by the weight in air, or call it the mass in air, subtract weight in water, or call it the mass in water. That's the apparent loss. That is how we can find relative density in solids. We can also find relative density in liquids using a similar technique. We can find the relative density of a liquid by finding the ratio of the apparent loss in mass of the substance when in the liquid to the apparent loss in mass of the substance when in water. Like I had earlier said, there is such a thing as apparent loss in weight of a substance or of a solid. Now, here we are trying to find the relative density in liquids. If I want to find the relative density of this liquid, for example, remember the water is more of our standard. We are trying to find the relative density. In other words, we are trying to find the density of this liquid with respect to the density of water. So, besides just getting the density of the liquid and dividing that by the density of water, we can also use this formula. It means that we are going to find the apparent loss, and by these are the procedures. This is how we go about it. It means that we are going to get a spring balance, measure this object or this solid in air, and then we record its weight in air. After recording its weight in air, we go get this thing and drop it in there, in this liquid X. Now, because of this upthrust force that I had spoken of earlier, there's going to be a reduction in the weight, a drop in the weight of this liquid while it is immersed in this liquid. And so it means that we are going to register a weight while this thing is in the liquid. Then we are going to get this same solid as well and drop it in water, and we are going to register another weight, another reading there, and we shall call it our weight when this solid is immersed in water. And of course, remember, because of the upthrust force in these containers, the weight in air is always going to be greater than the weight when this thing is immersed in this liquid, and it's also the weight in air is always going to be greater than the weight of this same solid when it is immersed in water. So what does that mean? It means that there is an apparent loss when this thing was dropped in liquid, and there's also going to be an apparent loss in weight when this solid was dropped in that water. So what does that mean? It means that if we find the ratio of this apparent loss, or we get the apparent loss in the liquid, divide that by the apparent loss in the water, we will be able to get the relative density of this liquid. So it means that the relative density here is going to be the apparent loss, which is given by the weight when the thing was in air minus the weight when it was dipped in the liquid. Divide that by the weight when the thing was in air minus the weight when it was immersed in water. So this expression is exactly what is explained here, that for liquids the relative density can be found out by finding the apparent loss in mass of a substance when in the liquid. The liquid can be anything. Divide that by the apparent loss in mass of a substance when it is in water. Like we said, mass and weight are directly proportional. So what does that mean? It means that it can still be apparent loss in weight of a substance when in liquid. Divide that by the apparent loss in weight of a substance when in water. And like I have been illustrating, this is what I mean: mass of the substance in air, or mass of the solid in air minus mass of that solid in the liquid, divide that by mass of the substance in air minus mass of that substance when in water. It's the same way the mass can be substituted by weight. Weight of the substance in air minus weight in the liquid, divide that by weight of air minus weight in water. This is the apparent loss in weight in the liquid, this is the apparent loss in weight in water. And definitely this is the same as saying the upthrust experienced when the thing is in the liquid, divide that by the upthrust experienced when the solid is in water. This ratio enables us to get the relative density of the substance. So we'll get to work out to do some worked examples in our upcoming videos. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.